So we are going to use the Laplace transform to find a solution of this integral equation. So what we would do first is, so we shall first try to identify this integral, and we are, this is a basic course, and you can see this immediately connects with this convolution of two functions. If you compare the two, here you got f of tau related to that, and g of t minus tau related to that, and this is convolution of f and g. So we have f of tau identified here. Let's go ahead and formulate our g. Okay, so as we just saw that g of t minus tau is tau minus t cubed, and to match it with the format in the convolution, we can write it as t minus tau cubed, and that immediately gives us what? Or rather, we can see or check that g of t is how much? Negative t cubed. So now we can rewrite this equation, okay, as the following equation, that this is 8 over 3 times the Laplace transform, f of t is 1 minus t minus 8 over 3 times f, the convolution of f and g. Now I just noticed, since the book is in front of me, that the question that you gave me has plus t here. So let's change it so that I am answering the question that you are having difficulty with. So now we are going to take the Laplace transform of this equation. So now we are going to take the Laplace transform of this equation. All right. So when we do that, what we get is, we will leave this LF as it is, and this quantity would become what? 1 over S. This is going to become 1 over S square. All right, and then here we have the Laplace transform of f times the Laplace transform of who? G, right? And remember this, we just determined that that g equals negative t cube. Remember, we did it just short while ago. Okay, so that's negative t cubed. All right, and then who is the Laplace transform of negative t cubed? Let me write it here for you. Okay, that will be negative 3 factorial over s to the power 4. Okay, so then we have this negative, and this negative will become positive, I'm sorry. A factorial 3 becomes a 6, and this 6 over 3 will change to 2. All right, and 8 times 2 would be how much? That will be a 16. So that's what we get. Now let's move this over to the other side of the equation. We will do that in the next step. So here we go. We got this here, and this will change sign. All right, and then we have this. Now we can factor this guy out, And when we do that, what will be left behind is 1 minus 16 over s to the power 4, and that whole thing will equal how much? That will equal this. Okay, now going further, and let me just do this like this here. Okay, I'll take s to the 4 as common denominator. Sorry about this long calculation. Okay, the book wants us to do it by hand, and that's what we are doing. All right, and there we go. So we have this, and if we multiply by the reciprocal of this quantity, what we are going to get is, we are going to get then s to the 4, okay, over s square minus 16 here, right? And the same thing over here. And when you simplify these, what you have then is, see, this is out, this changes to s cube, okay, this is out, this changes to s square. All right, and then finally what we have is, since we have common denominator here, we can change it to this. So our f is going to be the inverse Laplace of this quantity here that we have. Okay, now you know that this is not really that big a problem. Hopefully this thing will be partial fractions friendly. So let's just gather a little more patience and do partial fractions here. So if we use the partial fractions, we get what? S square minus 4 times who? S square plus 4. Okay, all right, and that further goes, okay, s minus 2, and then s plus 2. Okay, and then we will further do what? We can do this, take partial fractions as a over s minus 2, and if it works out, which I hope it would, nicely, so then what would happen is we shall be able to write the inverse Laplace transforms very easily here. So, and here I put a linear factor upstairs because I have a quadratic on the bottom. So then what will happen is, the thing that will happen is this here. I'm so sorry I had to endure a computer malfunction, and I'm fortunate that I was able to save at least this much. So anyways, so let's go back, and we are using the method of partial fractions with full force, with, all right, quite bit of force if not full. Okay, and here we have s plus 2, and then we got s square plus 4 plus b. I shall write this whole thing in here. Okay, and remove this because that is already compensated for here. Then we have C, and what shows up there is this, right? Okay, so and actually not C, rather we should have had CS plus D. I'm still emotionally recovering from that malfunction. Okay, so we got this right. Now we can go ahead and see what these all are. So this one, if we FOIL it, all right, this becomes that. This will become, if we FOIL this, this will be this, and let me FOIL the last one like by hand. So first I would do this, s minus 2 times s plus 2 becomes who? Square minus 4. So what that will be? CS cubed, okay, then plus ds squared. I'm still simply foiling. I might be fioling maybe, but that's all right. This is all this will come down to the same thing. Okay, so we got that. Okay, so what we have now is let's align it like slightly differently because otherwise it will not fit. Okay, so you have okay, you have this, and then you got a times who? You have a times this whole quantity, then plus b times who? This entire quantity, then plus we have CS, then we have, actually we will write it as it is because we multiplied them all together. Okay, now we will collect the coefficients of s cube, s square, s, and the constant that's left over. So for s cubed, what do we get? We get a plus b plus c s cubed, all right, then plus we have 2a, okay, minus 2b, okay, plus d, right, s square, okay, all right. So we have just a second, 2a s square minus, yeah, very good, plus d. Then we are going to write the coefficients of s, which will be 4a, okay, plus 4b minus 4c, we got an s here, then plus 8a minus 8b minus 4d. All right, so this is what we got. Now if we compare the coefficients here, what we get is we have this equal to 1, right? The coefficient of s square is how much? That is also equal to 1, and this quantity, since there is no s here, we will have it as 0 here, and then this also becomes a 0. Okay, now what we will do is we will use the method of augmented matrices. all right, instead of doing it by elimination. So what we can do is that we can form an augmented matrix for this system. Okay, so let's form an augmented matrix here. Okay, so we have 1 1 1 0 1, then 2 negative 2 0 1 1 again, then 4 4 negative 4 0 0, then we got 8 negative 8, no coefficient of c here, so we have 0 for that, negative 4 0. And just to let you know, remember this, if you look at the lesson 3, I have shown you here how to do that by using your calculator on pages 8 and 9. So let's go back to this. So what you do is that we shall get the row reduced echelon form. So what we get is our A, B, C, and D are these. Okay, and so let's write them down. And so here, and I'm going to use computer for this just to make sure that we compare our answers, and I think we are good. It wrote s squared plus 4 first, so C and D are both 1/2, all right, and A is 3/8 and B is that, right? So who our function will be then? Our function f will be, as we wrote before, remember what we are looking for? The inverse Laplace, right? So that will be the inverse Laplace of, let's take these all one by one so that we can compare, right? So here we have 1/2 times how much? 1/2 times s over s squared plus 4, okay, then plus again the same thing, and this time we have only how much? 1. Let's start doing this here. Let's start writing the constants outside, okay, just for sake of simplicity. So there you have 1 over s minus 2, and then I have here 1 over 8, okay, L inverse, and then what we get? 1 over s plus 2. Let's just write it again in a little friendlier form, that is, so here what happens is that we got 1 over 2 outside here, same here, 1 over 2 is outside. All right, now we will do this. You can see this connects with the sign of 2t, and this is e to the 2t. Now instead of just just speaking them out, why don't we pull up our list of Laplace transforms and then compare? So here is what we have to look at, right? Okay, so let's take it down here. That's what we want. Let me copy it properly. I'm sorry. Okay, so there we go. All right, where are you? Right here. Okay. All right, hopefully it will capture it. Okay, so there we are. Okay, and then let's just quickly go back and see the, so and here is what we have for our Laplace transforms. So let's take them there. Okay, all right, so here we go, we got these guys. So if you look at these, this just you know, you can see that this here corresponds to what? That corresponds to sine omega t, right? And then write this here will correspond to just for cosine, and then this is this and this are both corresponding with what? We have this and this going the same way, right? Okay, so if we look at this, since omega square is 4, that will become cosine of 2t, right? Now, for this one here, we need 2 2 in the numerator, which we can easily supply by just writing a 2 here, and we can pay for it here downstairs, right? So that 2, when we multiply by 2, will become a 4. So this will become what? Sine of 2t, and these two are straightforward, e to the 2t and e to the negative 2t. So going back here, all that we need is this, that this guy here is already in good shape and can be written as, sorry about that, written as cosine of how much? 2t. In this one we needed to bring a 2 here, that will become a 4, and we will write that in the next step. This will become what? Remember, if it's s minus a, it's e to the 8t, so s minus 2, so that's e to the 2t, and here what we will have? We will have e to the negative 2t, and let's just write one more step here, that this would be sine of how much? 2t, right? Okay, so let's see if we have the right answer, otherwise we will check for our mistake. Okay, it will be good to check for mistake rather than me being okay. So 1 over 4 sine 2t matches, this matches. Okay, all right, thank God. Okay, so we have the right answer here. All right.